Hey everyone, welcome to my YouTube channel. Today, we're diving into a world where the rules are completely different from what we see every day. A place where particles can exist in multiple places at once, information can seemingly travel faster than light, or at least, that's what it looks like, and reality isn't what it seems. Yes, we're talking about quantum physics. Quantum physics is one of the strangest yet most powerful branches of science. From particles that can be in multiple states at once, to computers that can solve problems millions of times faster than the most powerful supercomputers today. But where did this all begin? The beginning of the journey, Newton's big question, the story of quantum physics started with a simple question: why don't atoms behave the way Newton says they should? In the early 20th century, scientists realized that classical physics didn't apply at the atomic scale. When they tried to explain how electrons orbit the nucleus, a strange problem arose. According to classical laws, electrons should lose energy and spiral into the nucleus. But, as we know, the world doesn't work that way. This is where quantum mechanics was born. Scientists like Max Planck, Albert Einstein, Niels Bohr, and Erwin Schrödinger laid the foundations of this field. They discovered that energy and matter behave in tiny discrete packets, or quanta, at the quantum level. For example, light isn't just a wave, it's made up of particles called photons. Complex concepts in quantum physics. What truly makes quantum physics bizarre is the wave-particle duality and quantum superposition. A particle can be in multiple states at once until it is observed. This is exactly what the famous double-slit experiment showed. When no one was watching, electrons seemed to go through all paths at once, but when a camera was placed to observe, it looked like they decided to go through just one path. This highlights one of the strangest features of quantum physics. Observation affects the behavior of particles. This brings up the question, does reality only form when we observe it? Are we, in a way, creating the world with our observations? Quantum physics, at this point, crosses into the realm of philosophy, raising profound questions. Parallel universes and strange theories. One of the most mind-bending ideas in quantum physics is the parallel universes theory. According to this theory, when a particle enters superposition, all possible outcomes happen in separate parallel universes. So, perhaps in another universe, you're not watching this video but living on Mars. This theory aligns with ideas from parallel worlds and multiverses often seen in philosophy and sci-fi. Many wonder, do we only have one version of ourselves in this world? Or could there be different versions of us in other universes, each making different choices? Conspiracy theories in the quantum world. Alongside science, conspiracy theories often arise. Some believe that governments are already using advanced quantum technologies that are still unknown to the public. For example, quantum computers that could break modern encryption, or even the possibility of telepathic communication through quantum entanglement. Could this be real? Maybe the future will shed some light on these ideas. In this area, there's a lot of talk about quantum weapons and information wars. Could these technologies be used for mass surveillance? Given the rapid advancement of science and technology, it's possible that we'll see these things enter our lives sooner than we think. Future inventions with quantum physics. Imagine using quantum principles to create things like teleportation or devices that tap into unlimited quantum energy. Science is heading in that direction, and maybe not too far in the future, we'll see technologies that today are only seen in sci-fi films. Teleportation is one of those exciting ideas being researched in quantum physics. Scientists are looking into transferring information, or even matter, instantaneously from one place to another without physical movement. If this process becomes fully realized, it could revolutionize travel and transportation, quantum physics, and artificial intelligence. One of the most exciting areas right now is the fusion of quantum physics with artificial intelligence. Researchers are developing algorithms that use the power of quantum computers to take machine learning and data processing to an entirely new level. This could revolutionize everything from discovering new drugs to analyzing astronomical data. Quantum computers could perform complex computations at speeds that no classical computer could ever achieve. This technology could revolutionize scientific problems, from drug discovery to designing new materials. Is time travel possible? One of the most debated ideas in quantum physics is the possibility of time travel. Some theories suggest that if wormholes and quantum entanglement are properly controlled, it might be possible to send information, or even matter, back in time. But this is still purely theoretical. Who knows? Maybe one day, humanity will unlock the secret to time travel. If time travel becomes possible, it will bring up huge ethical and philosophical questions. Could we change history? And if we could, would changing the past drastically alter the future in ways we can't predict? Conclusion: the future of quantum physics. Quantum physics has not only changed our understanding of science, but it has also posed major questions about the nature of reality and the future of technology. Are we living in a world of infinite possibilities? Will quantum technologies transform our world? In upcoming videos, we'll dive even deeper into these strange phenomena and their applications. So, if you want to learn more, make sure to like this video and subscribe to the channel, because we're going to discover some mind-blowing things together. Until next time, see the world with fresh eyes.